Imagine standing inside a mountain more than 2,500 years ago. There are no machines, no electricity, no maps glowing on a screen, and no way to communicate through hundreds of meters of solid rock. Just the sound of iron striking stone, the flicker of oil lamps, and the hope that somewhere on the other side, another team is digging toward you. If either group makes the smallest mistake, years of work will be wasted. The tunnels will never connect, and yet they did. Thousands of years before modern engineering, ancient builders achieved something that seems almost impossible. They carved tunnels through mountains using only hand tools, fire, patience, and an astonishing understanding of geometry. Today we're exploring one of humanity's greatest engineering achievements, the invention of tunneling. Digging underground wasn't something ancient people did for adventure. It was a matter of survival. They needed fresh water in dry landscapes. They needed valuable minerals hidden beneath the earth. Armies needed secret passages beneath enemy walls. Kings wanted magnificent tombs carved into solid rock. These necessities pushed people to solve one of history's greatest engineering challenges. The earliest tunnels were actually mines. Around 2600 BCE, Neolithic miners in what is now England dug deep shafts into the ground, searching for high-quality flint. Using nothing more than picks made from deer antlers, they followed valuable stone wherever it led, creating a maze of underground passages. At roughly the same time, ancient Egyptians were cutting tunnels into the mountains of the Sinai Peninsula, searching for turquoise and copper. Every swing of the hammer was powered by human strength alone. These early tunnels weren't carefully planned. They simply followed valuable rock underground. But eventually, humanity faced a much greater challenge. Instead of following stone, could they dig toward a destination they couldn't even see? The answer came from ancient Persia. More than 3,000 years ago, Persian engineers created one of the smartest water systems ever invented, the Qanat. Many Persian villages were built far from rivers. However, deep beneath nearby mountains, groundwater was plentiful. Instead of carrying water across the desert, engineers brought the village to the water. Underground, they dug long tunnels with an incredibly gentle downhill slope, allowing gravity to move water naturally for kilometers without pumps or machinery. Along the route, workers dug dozens of vertical shafts. These shafts allowed fresh air to enter, provided access for workers, and made it possible to remove thousands of tons of rock in leather buckets. Working almost entirely by lamplight, these crews slowly connected each section until fresh mountain water flowed naturally into towns and farms. The idea was so successful that Qanats spread across the Middle East, North Africa, Spain, and Central Asia. Even more remarkable, some of these ancient tunnels still carry water today, but while Qanats followed gravity downhill, another civilization would attempt something even more daring. Jerusalem. Around 700 BCE, King Hezekiah knew the mighty Assyrian Empire was coming. The city's only major water source, the Gihon Spring, lay outside its defensive walls. If the Assyrians surrounded Jerusalem, they could simply cut off the water and wait for the city to surrender. So Hezekiah ordered an extraordinary project: move the water underground. Two teams began digging. One started at the spring, the other started from inside the city. Between them stood more than 500 meters of solid limestone. The tunnel twists and curves in strange directions, confusing historians even today. Perhaps the workers followed natural cracks in the rock. Perhaps they searched for softer stone. Or maybe, as the teams drew closer, they listened carefully for the faint sound of each other's picks striking the rock, changing direction whenever the echoes grew louder. Whatever method they used, they succeeded. Near the meeting point, archaeologists discovered the famous Siloam inscription. It records the incredible moment when the workers finally heard each other through the stone. With one final strike, the two tunnels became one. It's one of the oldest surviving eyewitness accounts of an engineering achievement ever discovered. But the greatest ancient tunneling masterpiece was still to come. Around 550 BCE, on the Greek island of Samos, an engineer named Eupalinos accepted what seemed like an impossible challenge. The island needed water from a spring hidden behind a mountain. Instead of going around it, he decided to go straight through it. The plan required two teams to begin digging from opposite sides of Mount Castro. If either crew drifted even slightly off course, they would completely miss each other. There were no compasses underground, no satellite positioning, no electronic measurements, only mathematics. Surveyors carefully measured the mountain above ground. Using geometry and triangulation, they calculated the direction each team needed to follow beneath the earth. The calculations weren't absolutely absolutely perfect. Near the center, the tunnels didn't align exactly, but by listening and adjusting during the final stretch, the workers corrected their course and successfully connected the passage. Even today, visitors can still see the slight bend where ancient engineers made their final adjustment. The Tunnel of Eupalinos remains one of history's greatest examples of ancient mathematical engineering. Then came Rome. The Romans transformed tunneling from a remarkable achievement into an everyday engineering skill. Their aqueducts often disappeared underground, cutting directly through hills instead of climbing over them. Roads passed through mountains using hand-cut tunnels. Entire lakes were drained through enormous underground passages. One of Emperor Claudius's greatest projects required digging more than 5 kilometers through solid rock using tens of thousands of workers over many years. Romans also turned tunnels into weapons. During sieges, soldiers secretly dug beneath enemy walls. Wooden beams supported the tunnel roof. Once the tunnel reached the correct position, the supports were set on fire. As the beams collapsed, the wall above crashed down with them, creating an opening for attack. Archaeologists have even discovered opposing Roman and Persian siege tunnels meeting beneath ancient cities, frozen in time for nearly 18 centuries. But how did ancient workers actually break through solid rock? Their most powerful tool wasn't metal, it was fire. Workers built large fires directly against the rock face, heating the stone for hours. Then they suddenly cooled it with water. The rapid change in temperature caused the rock to crack. Once weakened, hammers and chisels could break away the fractured pieces. This technique, called fire setting, was used by civilizations across Europe, Africa, and Asia for thousands of years. Ventilation shafts supplied fresh air, oil lamps provided light, plumb bobs kept tunnels level, simple surveying tools maintained direction, and above all, just patience. Some tunnels required decades of continuous work. Generation after generation slowly carved their way through mountains. The next time you drive through a highway tunnel or ride beneath a city on a subway, remember this: long before giant tunnel boring machines and laser-guided equipment existed, ancient engineers had already solved many of the same problems. Using nothing more than fire, hand tools, careful observation, and mathematics, they learned how to dig blindly through solid mountains and somehow meet exactly where they intended. It's one of the greatest engineering stories ever told, and it's a reminder that human ingenuity has always been our most powerful tool. If you enjoyed this journey into ancient engineering, don't forget to subscribe and let me know which incredible invention you'd like to explore next. Thanks for watching, and I'll see you in the next documentary.